Welcome to this little informational lecture on PCB routing. Obviously, if you're watching this, you're interested in routing a circuit board and the processes involved. So what I'm going to do is I'm actually going to show you an actual design that I'm actively working on right now. I'm probably going to speed this up for some content here and there because I will admit printed circuit board routing by hand does take time. There are tools. For instance, there are routing tools. For instance, there is this thing called AutoRoute, which does work sometimes okay. I do not use it mainly because to use it properly, you have to do a lot of configuration of the rules and the router, and then it will do a fair job if you know what you're doing with the router. I have found that the time it takes to configure the auto router and all the rules, I can pretty much do the same thing for that same board and get a much more denser and desired look if I do it by hand. It's just a personal preference. I know some people who professionally use auto routers and it works perfectly fine for them and actually does a fairly good job. Um, so it's strictly up to you. It's a personal preference. I personally prefer to do it by hand. That doesn't mean that you need to do that. It's not a requirement. So that being said, we're going to show I'm going to show here a sub-circuit of that I'm routing here. This is basically this dip switch here. And I'm going to show you it being routed with some resistors. There is a test point here, TP82, and just kind of show you and go through the process of placing the parts and the routing process, just so you can get an idea of what is involved in doing that. So what I'm going to do is I am going to show you kind of a simple sub-circuit on the design that I'm currently routing. This is a very big board. It has a lot of parts. In fact, it is a big board. I'm getting tired of routing it, to be honest. But this little subsection served as a good example of how to route and place some parts as an example for you. So what I'm going to do is I'm going to show you the circuit that's we're routing. So right here there's a dip switch, just simple on-off dip switch. There are 6 switches. This is in the end what this circuit is doing is it's setting some voltages through the way these get configured, and it's resistor chained. And the idea in the end you get a different voltage depending on the combination of the different switches. It's used for channel ID purposes for this device. Its true purpose is not really important for this exercise, but just to give you an idea, it's basically used to identify the circuit board to the host system based upon the voltage it reads. So we have 6 resistors here. We have 6 resistors here on the bottom. All of these are grounded on one side on the dip switch. Then there's some of these series resistors that get chained together. There's one resistor to ground. There is all of this is connected to ground. This eventually goes off to a test point and to an A to D converter to be read. We're not going to worry about routing anything past this point. We're just going to kind of route basically this portion right here. So obviously these are all the designators. So this is your schematic. So if you paid attention to the PCB lecture I gave earlier in the semester, you would have realized that we first have a schematic that is captured with all the symbols of the flow of the design. So this is the mental picture of your circuit. So this captures the thought of what you want the circuit to do. And we do it with these symbols that you're used to seeing for in all the classes you've had so far. And we have this switch that just basically turns it on and off. So obviously if the switch is on, this contact point here, pin 12, is shorted to pin 1, which basically makes this point here equal to ground. So that's basically from a circuit perspective what we're doing. Now that gets manifested from symbols into footprints, which is the actual component itself. And so these are the components already on the circuit board that were loaded from the design. So here's that switch 10, here's TP82, so on and so forth, and these resistors. So this is all grouped up here. Again, this is a much larger design, very large, and I'm going to be busy for probably at least another week on this. But at this moment, I'm just going to show you this particular subsection here. So what we're going to do is we're just going to come in here and start grouping components together. Now, what a lot of students do that I've noticed, and even a lot of designers in general, is that you'll see people just shove parts all random out here, um, and get connected to wherever it needs to go. For instance, R51, you notice it highlights here, kind of highlights a white line around it. This needs to connect here, this connects here, and people will just shove this stuff willy-nilly, nice official engineering term there, just out in the middle of nowhere and just connect a trace. Does that work? Yes. Yes, it does. Um, is that probably appropriate? Probably not. I mean, will it function completely? Yes, it would actually. For the purposes of the circuit, that would work. You'll end up with a design that takes up a ton of space. I mean, technically, I could leave these parts as it's configured right now, route the board, be a little creative around it. I have actually on this board, I have a total of 6 layers to work with. I could route this as is, as it's placed randomly right now, and it would work exactly as the designer has designed the circuit to do this. However, that is not how I'm going to route this. This board, I just kind of zoomed out, is very complex. It's got a lot of density to it. It's got a ball grid array, main multi-arm processor on it, and SD-RAM. This board is complex, so I need every available bit of area to be as dense as possible so that I can route the rest of the board successfully. For that purposes, I want to make sure that all the parts are near to the IC or switch or component that it's associated with, and the traces are as tight as possible. We also do that in case of certain signals. You actually want to do that from a signal integrity perspective. So sometimes it's beyond just will it work, kind of. It won't work if you don't route it tightly. So in this case, being that it's just a static ID, you could route this however and it will work. For some circuits, it really does need to be right on top of each other. But we're going to go ahead and do that anyway. It's good practice to do that. So what we're going to do is we're going to come over here and we're going to pay attention to R51. Our R551 is connected to 12, 52 is connected to 11, 53 is connected to 10, so on and so forth. 10, we got 55, and then 7 is here just grounded, so on and so forth. We get to see the pattern that's going on. For purposes that I can kind of see how to route this, I'm actually, since I can only share one screen at a time on this recording, I'm just going to let you highlight and take a look at this. Suffices to say everything is connected as it's supposed to be connected, and I'm actually going to take this and put this on my other screen. I have found multiple monitors to be valuable for doing design work. I know at the EDC there's large monitors you can do. Have one really wide monitor that would work just as fine as well. Altium allows you to open up as many windows as you want. I have seen people use 3 or 4 windows of Altium, all one application running at one time. I personally find that 2 is kind of optimal because I can put the schematic on one screen, the circuit board in the other, and I can go back and forth quite easily. So what we're going to go ahead and do is we're just going to go ahead and start routing this sub-circuit here. So I'll make sure this IO section is up on my monitor on the other screen. So I am simultaneously, I can look to the right and I can see the circuit as a schematic, and I look to the left here and I've got the printed circuit board layout. So let's go ahead and start here. So, just kind of shortcut keys. So with Altium, you can click keys on the keyboard. You can do things through the menus, obviously. But if you go to Altium, you can actually find their list of shortcut keys. Pretty much everything I do, I threw to the keyboard. It becomes almost second nature. For instance, Control F will flip the board upside down, which is great if you're working on the back side of the board. And, because if you notice the text here flips, all the text on the top side is now reversed. All the text on the bottom side can be read. So that's Control F, for instance, for flipping the board. Control C, Control V, copy and paste works just fine. Though typically I usually use that for cutting and pasting traces, which I do a lot of. And here, what we can also do, like if I want to flip this part to the other side, I can flip it and hit the letter L, and that flips the part from the top side of the board to the bottom side of the board. Now, a common question I'm going to get is, can you put parts on the bottom side of the board? Yes, you can. It's perfectly fine. Do this all the time in production. Circuit board sharps are able to do that. The advantage of putting parts on both sides of the board is you can make a very dense circuit. Now, if you have a board that has got parts everywhere and you got a ton of space, which in senior design, typically we don't usually have a size constraint, so you can spread out. And so you can put all the top parts on the top side of the board and everything will be fine. However, for circuit routing purposes, it might be more effective to put the part on the bottom side of the board. Do you know how you assemble that? You flip the board upside down and you solder. It's pretty easy. That's exactly what happens at the circuit board shop when they assemble these at various companies. We have a local company here in town actually does assembly services. There's one in Brenham that I'm friends with the owner, Bencor. The one here locally in town, Terry O'Neill owns. It's ARQ. And I'm also very good friends with the one up in Dallas called Circuit Design Specialties. And they're all assembly shops. Do you ever get a chance to go to an assembly shop and see the process of your circuit boards being assembled professionally? It is a worthwhile effort to see pick and place machines and computers and massive of people soldering circuits together professionally. It is definitely good to see because you get to learn how to make your circuits better and easier to manufacture because there are tricks to that. Now, that all being said, in this class, we don't pay for assembly services. You are the assembler. Now, if you want to shell out the probably $1,000 or at least several $100s to go get professional assembly done, I'm not going to stop you. I have no requirements on you assembling your circuits or not assembling your circuits. However, we as a university and as a department, we will not pay for an assembly service unless your sponsor of the project allows it, which is very, very rare. It does occasionally happen, but it is typically rare. That all being said. All right, so let's go ahead and get started. So we have here R551 is going to connect up to pin 12, and R563 also gets connected to pin 12. Now, I can leave them like this. The only problem is I can't put this part under here because for what reason? There's a switch here. So we got to pay attention to the mechanics of what's going on. There are physical components here. I cannot put a part under a part on the same side of the board. I can't put R551 on top of R563. I know it seems obvious, but you'll be surprised how often this kind of happens. Now, technically, design rule checks should assist you here. So what you do, we know this here. What I've decided to do, again, I'm trying to make this very tight and compact. In fact, I want to kind of get all the parts, basically, if you will, I want it all to be within kind of this spacing here, just kind of all right around the switch. So basically the switch is mostly defining the square area of the board that I'm going to use. So to do that, I'm going to put these resistors on the bottom side of the board. So I'm going to hit the letter L and I'm going to flip it upside down. And I'm going to literally put the chip like right here as close as possible. Now I'm going to have room for a via to come off to go to the back side of the board. I'll show you that in a few moments. So let's go ahead and get one started. I'll kind of make the designator flow up to the top. This one here comes off the same side. Again, I need to put it on the back side, so we'll go ahead and do that. I'll just kind of get this out of the way for the moment. So now I have two parts. I'll go ahead and put this part, this designator probably right here for the moment. I might move it because I'm going to have this kind of interfering in a second. So now we have these two all in the line, which is very nice because now if I drop a via somewhere in here, I can get to the other side. Now, 556, according to our schematic, goes between basically this resistor here and the resistor that will eventually go right here. So I kind of know this needs to be in the area. So we know pin 1. So we'll go ahead and move this here. And so kind of have something that looks a little bit like this. Now, thing is I notice is you have to have designators or some way of letting the assembly shop / you know what part goes where. These parts do have different values. So I'm going to go ahead and move things around a little bit. By the way, this pinkish text here is actually an assembly layer. I'll put it in a single layer mode, which, by the way, single layer mode is simply Shift and S. And you can see it just says switch 10, and it highlights the assembly. This is not on the actual circuit board. This is just in a drawing to assist it. My client here likes assembly drawings like this, and so that's what we get. So we end up with designators like this off to the side. Again, this is not getting printed or otherwise on the circuit board physically. This is just a drawing package. However, the yellow here, this what we call overlay, this will actually be printed, in this case, white silkscreen colored paint on the board. The copper on top layer is red, and the copper on the bottom layer is blue. And of course, we have these other colors in between. So let's just go ahead and go through the process of routing this real quick. So let's go ahead and bring this down a little bit, give myself a little space, and I'm going to go ahead and go through this process. So just saying what I've hit here, I've clicked the interactive route button, which these are all, by the way, built into the menu bar. If you right click on the menu, kind of this area up here, you can turn on all these little panels. For PCB layout, you want PCB standard, which is this panel here. This allows you to select things, filter, move things. You want utilities, which is just general utilities. I sometimes use this, but I use this specifically, setting the grid size a lot, usually on 5 mil grid. Then you have wiring. Wiring is what we literally are about to do, wire up a pin. So we got that. We have multiple connections, differential pairs. I usually use this primarily in most, which is Control W, but I usually click the button. And you can place pads and vias. So, and I usually, strangely enough, I cut and paste my vias all the time. So everyone's going to have their quirk and how they do things. You just get into a rhythm and you'll learn how to do this. This is a learning exercise. So this is all signal traces, by the way. So there is no power in any of this. There's no current really going through this. These resistors are 10 kiloohms, 90 kiloohms, 500 kiloohms. We're talking microamps at best. So I'm using the smallest trace that's going to be on this board, which on this board is going to be 5/1000ths of an inch or 5 mils. Another quick thing to show on here is how to switch back and forth between mils, thousandths of inches, and millimeters. You just click the letter Q. So you notice everything's here in mils. Down here at the bottom of the screen, everything's in mils. Click the letter Q, whoop, everything's now in millimeters. So of course, sheet settings are still set in mils. So everything's now in millimeters. So if I click on the part, it'll come up and give everything in millimeters. Click the letter Q, do the same thing, and the part's now in mils. So that's convenient because sometimes you work in both. A lot of data sheets are in mils, a lot of data sheets are in millimeters. It doesn't matter. At the end, it's all the same. It's just a length measurement. So I'm going to go ahead and I'm going to actually bring in a via that I'm going to be using. I use this via here all the time. This is a very tight design, so it's a very small via. It's a 21.654 millimeter or 6.654 mils, or probably millimeters. It's a little over half a millimeter wide by a quarter millimeter hole size. So this is actually a metric via, basically. That's what I use predominantly. I get them tinted. That size via I don't recommend necessarily for senior design because that is a really small hole in via. This is for a high density board. These are actually kind of expensive to build sometimes. So you probably use a more like a 15 mil hole and a 30 mil via for most of your stuff. If you're pushing current, you're going to want a larger via. You can't push amps through this. This is again microamps. So let's go ahead and get a via on here. Again, we can get it near the pad. You don't want it in the pad. You try to avoid in-pad vias. Can in-pad vias be done? Yes, but they do have disadvantages and they do cost extra money when you go through the process of getting the circuit board produced. Advanced PCB in our case probably will not do an in-pad via. They try to avoid those. Not to say that they won't. It's just, general rule of thumb. You try to avoid doing that. So I'm just gonna make sure everything is centered up here. And what I do is I literally are coming along. I hit Control X, I'm cutting. It auto locks into the center of the pad. I'm just making sure everything is centered up on the pad. And then if you notice, it kind of snaps to the center. So as long as I click on the bottom layer, it'll snap to it. And if you notice, basically, if there's overlapping parts, that's kind of a good thing to see. You notice as soon as I click the button, it gives me a choice. Am I wanting to move and change switch 10, or am I wanting to move and change R563? I want 563. So you click that. So now that's in position. So now I have that done. Let me go ahead. And again, I do a lot of cut and paste and copy and stuff. So now what you see me doing here, I don't know if you can hear it, I'm clicking the space bar. The space bar will rotate a trace or rotate anything. You can rotate a part. Let me show you. I can click on the part here and rotate it around. So that is a useful tool as well. So you use L to move back and forth the parts to a different layer, and then space bar to rotate. So it just becomes second nature. I don't even realize I'm doing it until I said something. So I just went ahead. I've now rotated this trace down here, and I'm going to place this trace. Now notice I have the trace overlapping this pad. So I'm going to go ahead and move this down a little bit. And what I'm actually going to do that is I'm actually going to type in a different number. So these are the coordinates of the center of the part. Of course, every device is a little different. So I'm going to push this down, and I'm just going to give myself a little more space. Strangely enough, I use locations and manually manipulate this a lot. I'm very particular about centering up. In fact, we're going to do one in a minute where I'm going to want this part to be perfectly centered between two. And I'm going to sit with my calculator and I'm actually going to compute that location. And I'm going to do that with my trusty calculator that's sitting on my desk. So I do this all the time. Do you have to do that? No. Again, it could be sloppy. It doesn't have to be exact. But I like my designs to have kind of an artistic look. I like a flow of a design. So I'm going to center it up. That's just what I'm going to do. You don't have to do that. Now on this other side here, I have this resistor up here that needs to be connected. Now, I've already got it on this bottom side, so I don't need to put another via in. I've already got it on the bottom side, so I just need to connect the top. So I'm just going to come and literally do that. Now the top side is connected. Now the only problem I'm going to have is going to be, so technically this whole branch sub-circuit is now officially fully routed. We have actually got R51, R563 connected to pin 12 exactly this piece. We haven't done the VDD up here yet. I can show you that real quick. And all I have to do that is just do this. And since I have a power plane, I just need to drop a via and it's automatically done for me. Very easy. So I'm going to just leave this for now. Later on, as I'm finishing this off, probably off camera, so to speak, I'm probably going to make it where there's a bar across all of these because again, there's not much current and I don't need a whole bunch of vias pinging the same thing over and over again. I just put holes in the board for no reason. So what we're going to do first thing is now start copying this because guess what? This is the same circuit over and over again. So I don't like doing extra work if I don't have to. I don't need to relay out the circuit. I already know what the circuit is. So I'm just going to copy all of this. And I'm going to copy this trace right here. And in fact, I need to lengthen this trace, actually. I say that saw that was not centered on the pad. So make sure everything's centered up. So I'm going to go ahead and copy. Do Shift S. I'm going to copy everything on the bottom layer first. So just literally drag and drop here, or drag, select, come back to the top layer. Even though it looks like it's selected, the top layer has not been selected. I'm going to copy the top layer trace here. And I'm going to copy, when I hit Control C, I get a little, reticle that I need to use. And I can set it to anything. It's a reference point. Since I'm wanting to copy here and I want to copy to all these other pads, I'm just going to copy straight from the reference point being the pad of interest. So I'm going to copy here. And now I'm going to place, 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 place. And pin 7 is a little different, but I'm going to copy it, just say I did anyway. So now we have this. So all I have to do now is start arranging components. So I'm going to Shift S back out and go, what's the next component in the chain? R552. Oh, there's 552 there. Put it to the other side and drag it down. The only thing I have to do is basically get the silk screen in the right location. Okay, that's pretty easy. How about R564? So take a look around here. If I can't find it offhand, I just hit J, letter J, jump component, and I type in R564, and it'll take me right to the part. So there it is. I'll show you another one here in a second. And now I can take that part up. It's the same format, so I just need to bring that right there. Now this brings us to the point I was mentioning a moment ago. Now I've got this silk screen. What do I do with this? It's going to be a bit of a challenge because I can't overlay. I don't want to lay it on the top of the pads because there's going to be solder there. And I'm going to have other parts over here. So this does complicate things a little bit. What I could do is I could put the text right here. I could space out either direction. I can move up this way or I can move down this way. Because I need to let the assembly shop know which this. I could also delete it and just use the assembly drawing, which in ball grid arrays, which actually this board has, I had to do that. You can't always put the silk screen on in extreme high density. But in this case, I'm trying to get high density, but it's not a hard requirement. It's a switch after all. It's not, the only parts that are going to go under this switch are the parts for the circuit. So what I'm just going to do, I just made the command decision, is I'm going to go ahead and put the text like this. And I'm going to take this part here, and I'm just going to drag it down and put it down here, which works. Again, there's no harm, no foul in doing that. I could also move up these parts just a little bit, just to say I did, just to make it a little tighter. So instead of making it where there's 743, I can make this say 750. And notice it crawled back up. So a little tighter. So that'll work. And of course, I'm going to have to fix this. So click the trace, just drag up the trace. Now I'm going kind of fast, and I'm sure there's a lot going on here. But the whole purpose is to show you a general flow. You can draw a new trace. I mean, if you wanted to, you could delete the trace. Just hit delete, the delete key, and draw a new trace. And you can just simply do that. You can also, with Altium, you can do, there's like a dozen different ways to do the same thing in Altium. So here, I'm going to hit Shift S just to be able to focus on the layer. By the way, Shift S or single layer is your friend in Altium. If you got a multi-layer board, you got all these silk screens and different layers. It's a way of just kind of crossing out the noise and focusing on your specific task. So I'm going to take this and just drag it up. So now, a moment ago, I mentioned how I wanted things to be centered. How are we going to do that? Which, by the way, just to finish real quick on this, I did change this. So I'm just going to copy, just literally deleted these. I selected this, Control C again. So I've got my reticle, put it on the center of the via, and I'm just now going to Control V and paste. So now these are all lined up. So now I want this pad and this pad. Basically, I want this part to be centered exactly between these two. How do I do that? Well, I'm going to type the command Control M, stands for measure. I get a reticle, and I'm going to start. Here's a reference point. I go here, and I've got 3.62 mils. I'm not too worried about the Y dimension. That's just spacing off the part. But this is what I want. I want this number to be the same as the other number. And I'm about to show you the other number. So 3.62 mils. So I'm going to put 3.62 in my calculator. Go from here to here, and I got 10. So I want it to be the same. So I put 10 in the calculator, add them together, 2 divide, and I get 6.81. I want this to be 6.81 mils from here to here. So how do I get that? Well, this was a 3.82 and it's supposed to be 6.81. So I take 6.81 minus 3.82. I need to increase going this direction to the right. I need to move this part to the right 2.99 mils. So I click on the part and go, okay, so I need to add 2.99 to 333 6.81, add. So my new x coordinate needs to be 3339.8. Okay, so just to verify things, I hit Control M again, check, 7.01, 6.61. So clearly I did something wrong. All right, so let's take that again. I must have not centered it or something, right? So 7.01, so you can just do it again. Don't you love it when things just go wrong? That's cool. So 6.61, 2 divide, 6.81. That's what it's supposed to be. So I must have just typed in something wrong. So let's be 6.81. This was, yeah, well, something, yeah, something doesn't make sense. It's supposed to be 6.81. Again, 7.01. 6.61. Yeah, 6.81. Oh, okay. I just didn't zoom in. Yeah, that's 6.61. Okay. So 6.61, 6.81, 0.2. So this needs to be, is just going to increase by 0.2, which is going to make this 4.0. So Control M again, just to verify. 6.81, 6.81. Yay, we got it. Okay. That was my Aggie for the day, right? Okay. So now what? Well, just need to connect this to this. I like the way that looks. Pretty cool. Just a nice thing. And again, I like some symmetry. So I'm just going to take this and now I've got this copied. Well, I can't put this here because it doesn't go on the pad. But here again, there's some little cool tricks on routing without him. So I could flip. That's useful, but that doesn't really do what I need to do. I literally need to mirror what I'm seeing. I need it to what we call rotate around the axis. So there are two keys for doing this, X and Y. If I click X, it mirrors in the X axis. So I'll click X again, it goes back, X again, it goes this way. And then there's Y. I can go this way. Basically Y, for instance, I can Y, you can see it flipping around. X, you can see it flipping around. So let's get over here, click Y again. So kind of like where we literally just started with, I click X and now it's mirrored and I just put it. So now this is completely centered. Now, why is this useful? Now is I can put the part designator under here and I can actually go on a single layer on here and you can see we've got our designators all spaced out. The part is completely routed completely under this switch. There's not going to be anything else under the switch. And we pretty much got the bulk of the circuit done. So now it really is just an exercise in cleaning things up. So let's just go ahead and do that real quick. So we now are just got to put all these other parts together. I can delete these. Excuse me. In fact, let me go ahead and lock. I'm going to do another little thing to, if you start dragging things around and that happens to you where the part you really don't want to move moves, you click on the part and you click lock. Later, I'm probably going to unlock it because I'm going to move this entire structure around once it's completed. So right now, let's go ahead and get all these parts where they need to be. So we need 553. So 553 is down here. Now I can drag this part around, but let me show you another shortcut key stroke. So we did earlier, we did jump component. So JC, literally the keys J and then letter C, and then you type in the key. So R553 took you to the part. Now it just jumps you to that part. Now that part's somewhere else on the board, it's going to take you all the way over there. Thankfully, it's right next to what we're interested in. Now, say I'm over here, I can't find R5. I'm blind. I just can't find it. So I can hit MC, move component, and then click MC, and then I type in R553, and now the part is automatically set to move. So I'm just going to shift it again, put it on the bottom side, and I'm going to come up here, and it had already selected that, but I want to see that it auto selected the top one, but this is set to go for pin 1. So I'm going to click pin 1, and I'm going to drag it down to the trace I'm interested in, and go ahead and do this, and I'm done. Let's go ahead and keep on going to the right here. So we got 554. So jump component R554. There's this. Switch it to the other side. I've learned, by the way, all of this, what you're seeing here is the control, and I have a mouse that has a scroll wheel on it. So if you hold the control key down, my pinky, it's almost, at this point, it's completely second nature. Don't even realize I'm doing it. I have my control key down, and I drag it, wham, all done. So we have that one, and we have one more R555, which zoomed out is right down here, and I'm just going to manually grab that. I'm going to grab it on pin 1 and come in, voila, there we go. And of course, I hit the space bar to rotate the text. Now let's go ahead and do this row of resistors. So we got 564, then there's 565, which is right there. Grab pin 1, hit L, it goes here, which that doesn't center up correctly. So I'm going to do pin 2. And we're going to delete all of these right here. We're going to delete all of these traces here, because we're going to be replacing them with this. So we're going to go ahead and do that. Now we're going to do 566. So there's that. Go off of pin 2 in this case is going to be our guide. Go ahead and move it down and move the previous one. And if you don't like the way the text is kind of like centering up, you can come here, take one that you like, 670, and just click all the texts and change it to 670, and it just flops in place. So we'll do the same thing for 567. Again, I'm very particular on my design. You don't need to do that. It is completely up to you how meticulous you want to be. 561 in pin 2, 561, and we do this. So now we have that all routed. There is no resistor to pull up here, so I can go ahead and just delete this. I remember that was just a cut and paste that we did earlier. So now we just have these, for the most part, this circuit actually does change a little bit towards we get to this side, but for the most part, it's identical going across. So I'm going to go ahead and just assume that for the moment and just give myself another couple of pairs of this, and go ahead and place these other few parts. So we have R557, we have 56, there's 57, go to the other side, and then it's pin 1 and pin 2, so we'll do pin 1, pin 2, and you can kind of verify, just so you know, if you want to verify things, you can take a look at the pinout numbers of everything. So actually, might be making a few changes here, because this actually, the circuit, now that I'm in this area, I'm seeing that it's not pairs like this, it's actually, these are in between. So I'm probably going to be making a few configuration changes. By the way, this is quite normal in circuit board layout. You just kind of assume maybe way a flow is going to work. You don't know yet. You're just putting parts in places and routing traces. So now it's like, okay, I need to make a few adjustments, because the circuit is the guide at the end of the day. So we know, looking at my other monitor, I'm inspecting him going, okay, this isn't what I was thinking quite as much. So I'm going to be a little audible in the spot, make a few changes. Now, Saying all that, how I noticed that real quick, of course, I've got right now, because it's such a massive board and there's so many errors all over the place, I've got the DRC error color, the bright ugly green, which flags errors, turned off, because otherwise this board would probably be a lot of bright green right now. That usually helps you. Don't usually recommend turning it off, because sometimes you'll forget to turn it back on. I'm definitely going to be remembering to do that, because this has got to go through DRC in the end, hopefully early next week. That being said, I noticed that because of this right here. The text on the pad says net R555 or 5562, and I'm like, oh, that's not this. That says 5531. So the net name kind of clued me in. Of course, you notice you click on it, it highlights this white. So I knew these two pins are side by side. So it's going to be kind of more like this. Same thing's true going to be here. So we're going to have to get things spaced out such that these resistors are side by side. So we have 558. Then apparently there's a 559. It kind of goes over here as well. So we get that over here. 5 that goes there. So, and this is going to get flipped around like this. So these two are together, these two are together, this two, these two. And then that's 559, and then there's a 560, kind of finishes off the chain. So let's just kind of get this cleaned up a little bit, and then we'll try to fix things. Let me go down here, kind of get everything centered up. And then we'll have to do a little manipulation of the coordinates so that I can get this laid out like I want. So let's take a look at this. So we have 1, 2, 3, 4. We have 5 values. So I'm going to go ahead and kind of delete all this because that's now kind of useless. I've got this actually backwards appears. This is the danger of leaving your stuff off. I've got these actually flipped upside down apparently, or at least that one was. So let me fix that. Again, this is an exercise of doing a real board layout live. This is normal. This is what you're going to be going through. It's okay. It's not going to be perfect on the first round of layout. So you just go through, manipulate, change, fix. Hate to break it to you, but also your circuit board, when you get it back, is probably not going to be perfect. There are going to be things you wish you changed when you solder it together. And there's probably the circuits. Something's going to be wrong. So you're going to have to fix it with blue wire and X-Acto knife and solder. That's normal. That's perfectly fine. The whole process here is about getting the circuit done so we can actually start testing it to fix it. So we know this is connected to that. So these happen to be all connected together. So this is connected to this. Let's see. I'm starting to get an idea of the flow here. And then this gets connected to here. This gets connected there. So I'm just kind of playing with the parts. I'm not set on anything yet. Of course, I do realize I'm doing with the silt screen, so I'm kind of keeping that in the back of my head. But I'm kind of getting an idea. So this here, I'm kind of seeing a zigzag pattern that I can kind of, you notice with my mouse, I can kind of see it in and out. So given that, I can probably do something like this, where these are down here. So I can give myself room to put my text. And then, just to say I did, put the text all down here. Not too concerned about, again, size is not too big of a problem. I'm just trying to get this as dense as possible. If I get into the rest of the layout and I've got real big size problems where this has got to be even denser, I might have to change things. But for right now, I'm not going to concern myself too much with that. So that was 515. Take a look here, bottom layer, make sure I'm not on the pad. I'm going to use this 500. So I'm just going to click all these, make them 500. All right, so now let's take a look at where we are. We'll go ahead and go off of, so go off of this x-axis. It's already on that. 3415, 3415. Just make sure these are all the same. I'm looking at this number here. 3515, 3560. So they're already centered up. Okay, so now we just need to connect everything. So, let's see. Doesn't really matter a whole lot. So this here, we're just going to route down here. And then this, this is going to connect here. And then this connects here. And then we're going to have a little, basically, kind of a, basically a little S, for lack of a phrase, sub-circuit here. All right. Again, I love symmetry. You can do that over and over again. Just keep redrawing it, or you can do what I do and just cut and paste. Because this is going to happen here, this is going to happen here, and it's going to happen here. No, actually, it doesn't. It goes here. Because this is the end. So like I said, the very end was a little bit different. So this one connects like this connects like this. And this one here, yeah, this one here connects here. So let's make sure this all flows. So all gets power. Again, this all gets connected together. Everything gets power. We come in, we get connected to the pad. This connects to the pad, connects to the pad on the other side, connects to the pad on the other side. These are all connected. This is all connected. Let's see here, 551.1, 551.2, or 552.1, 553.1, 554.1, 5551. So that's all connected together. Then this comes here to this pad, goes up here, connects here. That connects here. This one goes up to this one, comes around. This one comes around. This one's to all four of these to get connected. So, I mean, I could have just as easily done this. Works just as fine. In fact, I'll probably leave it like that. And then we have, this is the output that will eventually go to the analog to digital converter on the system. The only last part here, and we are pretty much done, is we have a 562, or actually two parts. We have 562, which according to this was a part that went over here and connected to ground. So I might change the way this works. And then this basically little test point here. This designer, because I didn't actually design the circuit. About once a year, I end up designing a circuit board for someone that I did not actually design the circuit. Almost every time I do it, I say I'll never do it again. And about a year later, I do it again. It's a theme. It's just a character flaw. I did it because, it was a friend of mine, a company I did some other design work for. And this is one of the, I don't like doing it because there are things on when you do both the schematic printed circuit board, you can make your life a little bit easier because you can move things around. I don't like changing people's circuits, so I'm sticking with their designs. So there are things that's like, oh, I've got to route it like this, and it's painful because that's what they want. There are a few things where I've had to change a few parts, like here I changed. These were all originally 0603 parts. I'm like, no, we're making these 0402 because this thing would have been spread. I would have had parts all the way out here if it was simply 0603. So that being said, we're going to go ahead and get this all finished up. So let's go ahead again and let's finish up this design. We had left only a couple of parts to just set up. So we pretty much have all of this subsection here routed. So again, we had this R562, just so that we can be consistent. I'm going to go ahead and pop that to the other side as well. And let's see where it connects. It connects right here. So I'm just going to go ahead and delete this trace for now. In fact, I'm going to do this. I'm going to delete this and I'm going to copy this. So just Control C as usual and just put this part exactly the same as if it was placed with like this one here. So in fact, I want it exactly on the same exact dimensions. Everything the same. So you can't even tell the difference. And then instead, this is going to get connected to digital ground, DG&D. And that's another explanation for another day. There are multiple grounds in the system. Sometimes you separate power ground, digital ground, analog ground, and you'll tie them all together at one point called a star configuration. It's a noise mitigation technique. But we won't worry about that today. So let's just get all of this connected here. You notice I'm using a larger trace for this. Everything we've been doing is 5 thousandths. This trace here we have set to 15 thousandths for the power. So we've gone ahead and done that. And that's connected there. So it's connected on the top side, all pins in here. And then on the bottom side, we have our bottom trace connected here. And then we literally just continue this exact same little S pattern that we have. Might as well use it again. And we'll connect that here. And now we have everything successfully created, except for now, one little test point. This test point, again, the designer of this pretty much has got test points all over the board. Test points are a useful thing, especially if you know this is a prototype. In fact, this board here is never going to be fully go to production. There'll be another revision before production. So this board is being specifically used for testing only to prove everything works. So there are test points all over this board to give you an idea of what this looks like. By the way, just so you know what I did is I hit the number 3 to enter a 3D view mode. And we're now zooming in on the part in question. So you can see how massive this board is. So we go ahead and we're going to zoom into this little switch module, this little dip switch. It's not CADed as a dip switch, so it looks like just a little IC package. But you can see it's a little test point here. You can clip your oscilloscope probe on it here. And then on the back side here are all the parts that we've laid out. Note the only thing we need to do is move this designator over and we should be good to go. So let's go ahead and finish everything off. Like I said, we just want to get this test point in a good position and we should be good to go. So let me go ahead and finish this up here. So we'll go ahead and move this designator here. So now designator's in the right place. And I'm going to go ahead and I'm going to actually put this test point, since this is only for testing only, I'm going to put the test point on, I'm going to leave it on the top side and put a via, just so that it's very convenient for him to come back and do testing here. I will put it on the same axis as this. So it's 601.38 mils. So I'll just cut and paste that and put it in exactly the same location. And I'm going to come off here with a trace. If I can grab one here, just do a Shift S. Just go ahead and go in single layer. Come here, come off a little bit. Use one of these vias that I've been using. And we'll just drop it here. And then all we need to do is take our 5 thousandths trace and just move forward. And of course, again, you can easily do all this with the interactive route tool, and you'll be able to do this. So there we go. There is the completed circuit. I mean, we could probably spend hours upon hours going over all sorts of different details on routing, but this is just going to be meant to give you a taste of routing a board or a subsection of a circuit. Obviously, doing a more complex circuit takes many long hours, so you do need to plan that. Typically, I say that most basic schematic pages should take me 2 to 3 hours to route. A board does not get routed in just a couple of hours. This board here, for instance, is about probably end to end, probably about 6 weeks of routing on and off. So but of course this is 31 page schematics, so it's and with BGA parts and everything everywhere. So this is not a very friendly board. Most boards usually take me just a few days to route. But you do need to plan accordingly. So you notice all the traces are nice and straight. There's not anything kind of all over the place. Everything has a plan and a purpose, and the parts are located near the net in question. So that was the main thing I wanted you to see. And again, just so you see the 3D view of this, we've got the vias, we got the part on the board, it's soldered. There's nothing under the part directly. We got a test point, and then right here we've got our resistors all located nice and neat, and everything is completely readable. So that's basically it. Just let me know if you have any questions by emailing me, and I will be glad to help you. Have a great day.